For centuries, humanity has looked up at the night sky and asked the same question. How old is the universe? It sounds like a simple question. But the answer may be far more complicated than anyone imagined. Today, scientists estimate that the universe is approximately 13.8 billion years old. This number is one of the foundations of modern cosmology. It shapes our understanding of everything, from the birth of stars and galaxies to the origins of space and time itself. Yet a growing collection of observations is forcing astronomers to confront an unsettling possibility. What if that number is wrong? What if the universe is older than we think? To understand why this question matters, we need to go back in time. Just over 100 years ago, astronomers believed the Milky Way was the entire universe. They saw our galaxy as the complete cosmic landscape. The idea that countless other galaxies existed beyond it seemed impossible. Then came one of the greatest scientific breakthroughs in history. In the late 1920s, astronomer Edwin Hubble studied distant objects that appeared as faint smudges in the sky. What he discovered changed everything. These objects were not clouds inside the Milky Way. They were entire galaxies. Massive island universes containing billions of stars. Even more surprising, they were moving away from us. The farther away a galaxy was, the faster it appeared to be receding. The universe was expanding. This single discovery transformed humanity's understanding of reality. If the universe was expanding, then it must have been smaller in the past. Tracing that expansion backward suggested a beginning. A moment when all matter, energy, space, and time emerged from an incredibly hot and dense state. The idea eventually became known as the Big Bang. For decades, evidence supporting this model continued to grow. Then another surprise arrived. In the 1990s, astronomers studying distant exploding stars discovered that the expansion of the universe was accelerating. Instead of slowing down under gravity's pull, galaxies were moving apart faster and faster. Something invisible appeared to be pushing the cosmos outward. Scientists called this mysterious force dark energy. To this day, nobody fully understands what dark energy actually is. Yet according to current models, it makes up nearly 70% of the universe. It dominates the cosmos while remaining almost completely unknown. Using measurements of cosmic expansion, the cosmic microwave background, and other observations, scientists eventually arrived at a remarkably precise estimate. The universe appeared to be 13.8 billion years old. Case closed. Or so it seemed. In recent years, however, strange cracks have begun appearing in this cosmic timeline. One of the most intriguing clues comes from an ancient globular cluster known as M92. Located within the Milky Way, M92 contains hundreds of thousands of stars packed into a relatively small region of space. It is one of the oldest known stellar systems in our galaxy. Astronomers have spent years studying these stars because they act like cosmic fossils. Their ages can reveal valuable information about the early universe. But the results have been surprising. Some estimates place M92's age astonishingly close to the age of the universe itself. In other words, these stars appear to have formed almost immediately after the Big Bang. That presents a challenge. Stars require time to form. Gas must gather. Gravity must do its work. Complex structures must emerge. Yet objects like M92 seem to leave very little room for that process. It is as though the universe started producing ancient stars almost as soon as it came into existence. Then came the arrival of one of the most powerful scientific instruments ever built. The James Webb Space Telescope. Designed to see farther than any previous telescope, Webb allows scientists to look deeper into cosmic history than ever before. Because light takes time to travel, observing distant galaxies is like looking back in time. The farther away an object is, the younger the universe appears. Scientists expected Webb to reveal small, primitive galaxies in the early cosmos. They anticipated seeing the first building blocks of larger structures. What they found was something entirely different. Many of the earliest galaxies appeared surprisingly large, surprisingly bright, and surprisingly mature. Some existed only a few 100 million years after the Big Bang. Yet they already seemed highly developed. According to traditional models, galaxies that massive should not have had enough time to form. The discovery stunned astronomers. Were these galaxies somehow growing faster than expected? Were existing theories incomplete? Or was there something fundamentally wrong with our understanding of cosmic history? These questions have sparked intense debate throughout the scientific community. Some researchers argue that galaxy formation in the early universe may have been much more efficient than previously believed. Others suggest that important ingredients are missing from current models. And a few scientists have proposed something even more radical. What if the universe is significantly older than 13.8 billion years? Could our cosmic clock be running on flawed assumptions? Could the true age of the universe be far greater than anything currently accepted? For now, no one knows the answer. What is clear, however, is that the universe continues to surprise us. Every time we believe we have solved its greatest mysteries, new observations challenge our assumptions. Ancient star clusters. Unexpected galaxies. Questions with no easy answers. Together, they are forcing scientists to reconsider one of the most fundamental ideas in modern cosmology. And if these mysteries continue to grow, they may eventually lead to a completely new understanding of the universe itself. Because sometimes the biggest discoveries are not the answers we find. They are the questions we never expected to ask. If ancient star clusters and unexpectedly mature galaxies were the only mysteries, astronomers might have already found answers. But the deeper scientists investigate, the stranger the story becomes. One of the most famous cosmic puzzles centers on a single star. A star so old that, according to some early calculations, it appeared to be older than the universe itself. Known as the Methuselah Star, this ancient object lies roughly 190 light-years from Earth. When astronomers first estimated its age, the results were shocking. The calculations suggested the star could be more than 14 billion years old. That created an impossible paradox. How can a star be older than the universe that produced it? Although later measurements reduced the uncertainty and eased some of the tension, the Methuselah Star remains a reminder that our cosmic timeline is not as secure as it once seemed. And it is not the only challenge. At the center of modern cosmology lies a growing problem known as the Hubble Tension. This issue concerns one of the most important numbers in astronomy: the rate at which the universe is expanding. Scientists have two primary ways of measuring this expansion. One method examines the early universe using the faint glow left behind by the Big Bang. The other studies nearby stars and galaxies in the modern universe. In theory, both approaches should produce the same result. But they don't. Again and again, the numbers refuse to match. The difference may appear small. Yet in science, small differences can point to enormous discoveries. Some researchers believe the Hubble tension could be evidence that our understanding of dark energy is incomplete. Others think it may signal entirely new physics waiting to be discovered. And if our measurements of cosmic expansion are wrong, then our estimate of the universe's age could also be wrong. This possibility has inspired a bold idea. What if the universe is not 13.8 billion years old, What if it is much older? In recent years, some theorists have proposed models suggesting the cosmos could be nearly twice that age. One controversial estimate places the universe at approximately 26.7 billion years old. Such a revision would dramatically alter our understanding of cosmic history. Ancient galaxies would suddenly have more time to form. Early structures would become easier to explain. Several current mysteries might fit together in ways they do not today. But changing the age of the universe is not a simple adjustment. It would require rethinking some of the most successful theories in modern science. And that is why the debate remains intense. Yet even more radical ideas exist. Some scientists have revisited an ancient concept known as the cyclic universe. In this view, the cosmos may not have begun with a single Big Bang. Instead, it could pass through endless cycles of birth, expansion, collapse, and rebirth, each universe giving rise to the next. Again and again.